Okay, so in question 4 it's asking you to draw the arrangement of ions in the crystal of cesium chloride. Well, you know that cesium's in group 1, chloride's in group 7, so therefore cesium needs to lose 1 electron to get an empty outer shell, chlorine needs to gain an electron to get a full outer shell, so therefore the ratio is 1 to 1. So we need to have a system for every positive ion. There is 1 negative ion next to it, and for every negative ion there's positive ion next to it, and we need to have that happening in 3 dimensions in a cubic shape. So you got 1 mark for the positive negative, and you got 1 mark for the 3D shape. So each positive ion is surrounded by 6 negative ions, 1 in each face, and each negative ion is surrounded by 6 positive ions, 1 in each face. The question was, why does cesium have different structure to sodium chloride? And the answer is because cesium is larger, therefore the 3-dimensional shape it can make is bigger, and therefore it can have more chlorines around it. In the bonding in graphite, the carbon makes 3 bonds. You've got a hexagonal structure with layers. So you could have got these marks by drawing a labelled diagram and showing the different layered structure with the intermolecular forces between the layers. Okay, so the hexagonal structure, and then obviously there being delocalized electrons between the layers. Okay, the next question was looking about why graphite can conduct electricity but diamond can't. It's because graphite contains delocalized electrons, whereas diamond doesn't, because each carbon is bonded to 4 others, and therefore there are no delocalized electrons. In the final question, in question 4, it's asking you to compare the relative boiling points of iodine and diamond. So the first thing you need to recognise is that iodine is simple covalent, so therefore you're talking about breaking intermolecular forces, whereas diamond is giant, and therefore you're talking about breaking covalent bonds. So that was your first mark. Your second mark was for saying that iodine had only London forces, and therefore they were very, very weak, whereas diamond had covalent bonds which were much, much stronger. And the third mark was therefore saying that significantly more energy was needed to break the bonds, the formal covalent bonds in diamond, than the intermolecular forces between separate iodine molecules. And you need to highlight that the intermolecular forces were between separate molecules.